Good morning, students. This is digital communication. Here, unit 1 is information theory. Here, discrete memoryless source information, entropy, mutual information, and discrete memoryless channel, and binary symmetric channel, channel capacity, then Hartley-Shannon law, source coding theorem like Shannon-Fano and Huffman codes are available. Now we see about discrete these are all the syllabus point of information theory of unit 1. So now we move to the discrete memoryless source. Okay. So what is discrete memoryless source? So before that we can go for what is an information theory, right? It is always used to design a mathematical model for analyzing the communication system. So already we know the basic idea about that for communication system. Simply we can say that is the transmitting section, so intermediate channel system, channel process, then finally we have the destination side receiver is available. So first of all, information theory means that is information is the basics of message source. So it may be the voice signals or in the image signal or in the video signal, how it is moved to the channel. So then it is finally go to the receiver section. So in between we have to get the clear information. So that's why we go for the information theory. Here see the Shannon's, instead of that is Shannon's channel theorem is always available. Then what is Shannon's channel theorem means the performance of the communication system is measured based on the transmitted signal, that is power, noise and bandwidth. So it is the main process of the information source. Okay, then we want to give the errorless transmission. No? So at a time the errorless transmission is possible when the probability of noise or error at the receiver should be 0. Then only we can get the clear information. So whenever we have to give the clear information, then only we get the output is in clear one. So that is the motivation of the information theory. So the first we can go for that the discrete memoryless source, right? Then here uncertainty is available. The output of any information source is random. Then consider the source which emits the discrete symbols randomly from the set of alphabet. Okay, so previously I told that the previous slide that is the some mathematical tool is possible for the information source. Here the random method is also, there is a random process method also followed. So here see, there is a x equal to x naught, x1, x2, etc. x of n minus 1. So number of symbols are possible. The various symbols in capital X have probabilities P0, P1, P2, etc. So X is the symbol of the values. If you consider as a probability, at a time we can say P0, P1, P2, etc. Right? So now we write the calculation. P of capital X equal to xk, that is pk, isn't it? So k is equal to 0, 1 to etc. k minus 1. So this set of probabilities satisfies the following conditions, that is summation of k equal to 0 to k equal to 1, that is pk equal to 1. So this information source is called discrete memoryless source, and idea of the information is related to uncertainty or surprise. So first of all, what is an information? So let us consider the communication system which transmit messages. So messages, it may be the, already I explained, that is that it may be the voice signal or in the sound speech. Okay, voice in terms of we can say, so that is a speech. Okay, speech we can say audio signal and image and video. So like that we have some information, otherwise it is called as the messages. So that's why here we have to denote it as M1, M2, M3, etc. number of messages with the probability of occurrence, that is P1, P2, P3, etc. The amount of information is given by ik is equal to log base to 1 by pk is equal to minus log base to pk. So this is one of the information formula. Okay, so all the formulas, all the technique that is used in terms of random process method. Okay, unit of information is denoted by bits. Okay, now we see about properties of information. If there is more uncertainty about the message, information carried is also more. Okay, if receiver knows the message being transmitted, the amount of information carried is 0. Then if I1 is the information carried by the message M1 and I2 is the information carried by M2, then amount of information carried componently due to, so how we can calculate M1 and M2 is I1 plus I2, that's all. So if there are M equal to 2n equally likely messages, then amount of information carried by each message will be n bits. Thank you, students.